been putting off learning Factorio circuits for ages. They seemed really complicated, but today I finally gave them a try and discovered they're actually incredibly simple to implement in really powerful ways. Today I'm going to show you how to build a basic train station priority system from scratch using just a few combinators. So what we're building here is a system that sets a train priority, which is this low variable in the train stops, that decides whether the trains pick this station or not. Now, we're gonna base this priority on how full or empty the chests connected to it are. For loading station, the full chests will get a high priority, whereas for unloading stations, the empty chests will get higher priority. This makes the trains automatically go where they're most needed. Now let's start with a basic train station. Here I've got 12 basic steel chests. The key is connecting all of these chests with a cable, this being a green wire or a red wire. You click on them and you plug them into the network. Finally, after this daisy chain, I'm just gonna connect that to the medium electric pole right here, and that's it. Now this signal, if you look at it, I'm gonna fill this chest a little bit. Ooh. And you're going to be able to see that this medium electric pole now has a signal which displays the amount of iron ore in this whole system. All these chests will be connected to this. So the first thing that we need to do is set up a constant combinator. This is going to display our stack size. I'm going to call it S. It's going to be a 50 because there's 50 iron ore per stack. Now, let's start with the arithmetic combinators, which are the funny ones. I'm gonna place 4 down for now. Don't get scared yet. The first arithmetic combinator is gonna just get our item count, which is iron ore signal, as we saw, and it's gonna multiply it by a constant of 100. I'm gonna set this constant here, and the output signal, let's just call it C for count of items. We're multiplying it by 100 because we'll be using percentages. I'll show you in a minute. Now, all we have to do is hook up this green wire to the input side, which is this one, of the combinator. Now you can see the output signal is already outputting 45,000. That's great. Now the next arithmetic combinator, we're gonna take our stack size of S, and we're gonna multiply it by 576. This effectively calculates our maximum amount of items allowed in the entire chests. So you can tell it's 12 chests, each chest has 48 storage, and each storage holds 50 items. This is basically calculating the maximum amount of items that we're able to hold in this. Because this combinator needs the signal S, we take the wire, we get the constant combinator, and we plug it into this end of the combinator. There we go, output signal 28K. Great. Now this third combinator is where it all comes together. We're going to get the signal C, which is the count of items. We're going to divide it by the maximum amount of items allowed. Now we multiplied C by 100 before, which is why we're going to get a percentage amount of fullness of our station. Let's call that F for now. Now, because this combinator needs both C and M, we get the output ends of both of these combinators, and we plug it into the input. There you see F is currently at 1. Why? Because there's a few items here, the rest of the chests are empty, therefore our fullness is set to 1. Now, if you're only building a loader station, signal F can directly, as I'll show you right now, can go into this pole and into our train station. Now in this bit we can set the priority of the station to F, and you can see the priority is F. This is going to get automatically updated whenever we fill our station with a few more items. You can see the priority is 3 right now. So that's it for the loading station, but if you want to make an unloading station, well, we only get the percentage of fullness. You would probably want to get the percentage of emptiness for an unloading station. To do that, all you have to do is connect the output to the input, and now we can get the F signal, fullness, sorry, we can get 100 and subtract our fullness from it. This way, if fullness is 3, then the emptiness is 97. We can call that, let's call it P. Now if we hook that up to the other pole again, we can select in this dialog whether we want the priority to be based on signal F or whether we want it to be based on signal P, depending on whether we are making a loader or an unloader. Now this priority, as I already said, is going to be updated dynamically based on our station fullness, and the trains will automatically come here whenever they spot that station with a high priority. Do remember to set your train stop names correctly. All iron loading stations should be called iron loading station or whatever naming convention you pick, and they all should have the same name. Same goes for iron unloading stations and each resource specific stations. Now, if you want to modify this blueprint, all you have to do is change the stack signal to whatever the stack amount of your item is, and change this signal here to correspond with the resource that you're trying to move. So if you're moving iron plates, I would change this to iron plates, and I would change this to 100, which is the stack amount for iron plates. And I can see if I put some iron plates in here, that the priority increases or decreases depending on which signal I pick. Now, if you want the blueprint, I've posted it on Factorio Blueprints. It includes both loader and unloader blueprints for a simple 12 chest station. And I hope this gets you started in learning a bit about combinators. I'm sure I will. And there we go. Thanks for watching.